I'm going to go ahead and get started. So for the first time speaking at ShmooCon this year, please give a warm welcome to Brandon, who will be talking hunting through for adversaries through scheduled talks.
Well, good morning, everyone. Thank you so much for coming to this talk. As you said, super honored to be speaking here at ShmooCon. I got to come last year for the first time, absolutely fell in love with the conference, and was luckily selected to talk this year. I know this is a longer talk, first thing in the morning, but hopefully I'll be able to make it worth your time and help teach a couple things. And by the way, all of the resources and everything that I'm going to have in this, including all the script files, and I've got some Docker containers, all that's going to be available on my GitHub, which I'll definitely have a link at the end of the presentation for you all. So good stuff at the end, so you have to suffer through my presentation first, and then you'll get access to that. So about me, full-time I work as a principal security author at Pluralsight. Pluralsight's an education company. Most of the time I do research and create video and hands-on content focused on things like incident response and threat hunting. Part-time I'm also a member of the Florida Air National Guard. So please don't hold that against me, but I do defensive cyber operation kind of things. That also means that I'm freezing all the time because it's so cold in here and cold in DC in general. So I might be just shivering nonstop. Socials are at the bottom, but without further ado, let's go ahead and just dive into this. So I'm going to start with a bit of just introduction and talk about detection. I don't want to focus too much on detection, but it's worth talking about. The majority of the talk and the presentation is going to be in that PowerShell and dashboard analysis piece, because what I would like to focus on is, okay, we can detect new malicious scheduled tasks as they're created, but what about all that stuff that already exists inside the environment? How do we look for those? And it turns out it's a little bit more complicated than I initially thought. And then hopefully have a little bit of Q&A time at the end. So persistence techniques, MITRE maps out 19 different persistence techniques. There's quite a few of them. And I always considered scheduled tasks as a very low-level persistence kind of thing, very easy to do, easy to detect and find, or so I thought. And so I never really gave it a lot of thought, of course, until I did. I was very much focused on things like registry persistence or starting up as another application starts up, or really hidden, cool, exciting things. And I left this to the side. But I have dug in deep, and so I'm specifically focused on Windows scheduled tasks. No surprise here that many named threat group actors are using this persistence mechanism, and so it's something that pretty much everybody should be concerned about. Everything from the low-level groups all the way through to your APTs, and this is often used as a backup or additional secondary or tertiary persistence mechanism. So they're going to try to persist in multiple different ways, and if they can just add in another scheduled task while they're doing those other things, they might do so. So definitely something to be worried about. Okay, so let's talk about detections. Let's say we're doing this right. We want to be able to detect new malicious scheduled tasks as they're created. There's lots of resources out there that will talk about, hey, here's what you can do to go detect the scheduled tasks. Starting with command execution. So you can say, yeah, we'll monitor for command execution for when the scheduled tasks are created. But as you dig into that, it's more than just CMD execution of the big things. You can also create scheduled tasks through WMI. You can also use PowerShell, and there's multiple different ways which require multiple different sets of logs to go and analyze. And so as a security analyst, if you're trying to dig through all that stuff, you typically have to rely on something like an EDR to give you the right information if you're not already overwhelmed with the just massive amount of stuff that exists. Some other resources will say, well, you can look for files being modified. Scheduled tasks actually exist inside system root, inside system32, and in a directory called tasks. Every scheduled task is an individual file inside of that. And so theoretically, you could just look for modifications or new files created inside this directory. If you've ever had to do like enterprise-wide file modification analysis, that's not sustainable. And that's miserable by itself. So probably not the most efficient way to do that, but theoretically, I guess it could be done. Similar to command execution, you've got things like process creation. Again, just massive amounts of metrics and analytics to kind of dig through. Registry key creation always pops up, and I love when they say, yeah, just look for new registry keys being created in all the places that a registry key could exist to do the thing. Yeah, that's not sustainable either. So the last thing that I'll bring up, and this is probably the correct way to do detection for new scheduled tasks. If you have sysmon enabled in your environment, it has the ability to detect scheduled tasks and give you additional metrics on that. And then Windows logs, events 4698 through 4702 all have to do with scheduled tasks. Point of note, none of these logs are enabled by default. So you actually have to go into your enterprise, you have to enable that logging, and then you have to go look for the thing if you're concerned about scheduled tasks as a persistence mechanism. Okay, that's detection. So that then begs the question, okay, now we're going to go back, we're going to enable that detection, we've got those logs, and we can look for malicious scheduled tasks. But what about all the scheduled tasks that already exist inside of my environment? What about if any of those are malicious? And so that's what I'd like to focus on, because that's what I was interested in. So we're going to start with some PowerShell analysis, and this is probably where some of the misery starts for all of you, but I'll try and make it not so terrible. I have a demo. The last few presentations I've given at a couple different conferences, my demo has gone absolutely terribly. I don't know if I gave enough sacrifices to the demo gods or whatnot, but it hasn't gone well. And so I've actually recorded the demo this time, so it should go smooth. Of course, I did that, and we're going to have all kinds of AV issues, so we'll see. As it's up, we'll see if we can get through this. Okay, so I've got VS Code up. I'm inside of a build. This is a Windows 10 brand new build. I've emulated an attack on it, so it's got some other things. There is one malicious scheduled task within this environment, okay? And so we're gonna go find that, but the get scheduled task commandlet, we can do a .count, and we can see that this endpoint has 148 scheduled tasks by default. Well, plus the one, so 147 plus one malicious one, and that's super normal. Windows 11 has about 160, and then my daily driver that I've used for a couple years, it's at almost 300 scheduled tasks, which is insane to me. And so when you expound that problem to an enterprise, and you talk about thousands of endpoints and trying to sift through those scheduled tasks, that's a lot of work. Okay, so what can we do then? As a typical threat hunt process, the next thing that I'm generally interested in is what kinds of information can I pull back? What are the fields, what are the data points that I can see? Because at its core, threat hunting is really nothing more than saying, okay, I know what normal looks like, and I really just need to find the things that are abnormal. And within those abnormal things, I can hopefully find the malicious stuff, and hey, that's like threat hunting at its core. So getMember allows us to see all the fields that get returned. We see things like author and date and description, metadata information about the scheduled task as it's created. In PowerShell, you'll also see this thing here for instance array. So each one of these properties then has properties that have an array of properties inside of it. And so you've got to dig a little bit deeper if you want stuff like the action or what is actually being executed within this scheduled task when it starts up. So we can do get scheduled task.actions, get member for that, because that's probably what we're interested in, right, is the execution or processes, applications that are running. And then we can see things like, this is the problem with recording the demo, I've got to wait for the recording to go through. We can see things like the execution and the arguments. So this is that application, any additional arguments that's executed alongside of it, so on and so forth. Okay, so we're digging through those, we're getting all the metrics for it so that we can now make a more informed query on the kinds of information that I want to return. And so if we do a getScheduledTask.action.execute, this is going to return a long list of all the execution parameters, aka what application is being executed. We see defrag exe, tz sync, so on and so forth, just massive list. Let's clean this up a bit. We can group the objects by that property and then sort them so we get a nice counted list of how many times each one of those applications was returned. Okay, cool. Here's where the misery really starts to begin. What you may notice here at the bottom, so this first column here is a count of how many times it was seen. At the bottom, we've got 73 results where there's nothing in the execute field. So Microsoft does this really cool thing where they say, we've got some scheduled tasks that we want to run on the back end, but you as a user, oh, by the way, you as a local administrator or even domain administrator, you don't really need to know the details of what we're doing. So we're just going to hide that from you. Cool. Thanks. That's super helpful. I'm sure an adversary would never take advantage of something like that to just hide all the execution details in a scheduled task. Super helpful. Okay, that piece aside, by the way, and that's legitimately how they do it, whether those are active running scheduled tasks or not, and we'll look at a couple other properties that make this more difficult. But there are some that we can see the details for. So most of these are returning back with things like windir or in system root. And so as part of trying to find like an easy win or something that might stand out a bit easier, I'll filter out both of those results. So filter out anything that says windir or system root in it, and we get a slightly smaller list of things that are executed. Okay, now looking through this list, a lot of stuff executing in program files, applications as they should. One thing starts to stand out is that sc.exe by itself, without an absolute path. So sc is used to start up services. If I'm thinking about what an adversary may do, they may be using sc to then start up some service as part of a persistence piece. So if we wanted to dig into that, we could then say, okay, get scheduled task. We're going to filter for execute equal to sc.exe and return those details. When we do so, at the core, we're going to get that high-level metadata stuff. So we see the task name here is set to UPnP host config, UPnP probably universal plug and play. We can see the task path or the folder structure that it sits in is inside Windows or Microsoft Windows UPnP. And then if we want that execution details, we have to run the same query but just pull back execute and it returns what was actually ran or what is supposed to run on the scheduled task. So there's the sc.exe, and now we can see the arguments. This is config UPnP host start equals auto. This is legitimately how Universal Plug and Play, or UPnP, is started, built in as a scheduled task. They just didn't give it the absolute path to sc.exe, which is a little weird, but not outside the realm of something that Microsoft would do. And this kind of also gives a little insight into the threat hunting process. I talked a bit about like how simple it really is at its core, but 99% of the things that you get back is, oh, this looks weird, but it's actually a legitimate thing. Welcome to threat hunting. Okay, so false positive, great. What else can we look for? Well, we see the arguments there. Maybe there's interesting things in the argument details coming back. So we can do the same thing, pull back actions.arguments, return a massive list of all the interesting stuff there. Now, thinking a little bit more about, okay, maybe the adversaries like to use PowerShell. And so now I want arguments where PowerShell is listed out in any of those execution details. So I'm going to filter on that same argument field, but now return back anything that has PowerShell in it. And we have two results. So let's look at this. The execute, or that parent process that spawned, is cmd.exe that then launches PowerShell as a child process, or as that sub-argument underneath it. PowerShell is then executing with let's count them, no profile, non-interactive, no logo, setting the execution policy to unrestricted, and then calling a PowerShell script file. Okay, going through my security mindset here, that looks super malicious, right? The second result does the same thing. This first one calling an initialize instance.ps1, second one calling an ec2 launch.psd1 file. So super cool, this is exactly how Amazon spins up every EC2 instance in the cloud. Thank you, that's super helpful. So we can see how the miserable journey that I went to try to find these anomalous tasks, it makes it very hard to find the things that are anomalous when the legitimate companies are making tasks that look super anomalous. Cool. Okay, so arguments, oh, and this should also demonstrate why it's really, really important to go through your environments and learn what things are in existence or what things are being executed so that it's easier to find those truly malicious anomalies. So this next part, I'm going to walk through a couple different fields that might help narrow us down into some more anomalous things. There is a task path. This is the logical folder structure where each of these tasks exist. Most of the tasks exist inside the Microsoft Windows directory. Okay, most of them are Microsoft scheduled tasks as created by default, especially on a brand new build like this. So we can then say, okay, show me all the scheduled tasks that don't exist inside the Microsoft folder. So should be the non-Microsoft scheduled tasks. So right up there at the top, we see the 2 Amazon EC2 launch scheduled tasks. Below that, we have something really interesting here. We've got Microsoft Edge Update and OneDrive. Okay, so you're telling me that Microsoft created a directory called Windows and Microsoft and then created scheduled tasks and didn't put them inside the directory that they created. Cool, thank you, Microsoft, super helpful. Yet another instance where they're just not consistent to their own standards, making it that much more difficult for the defender. I mean, to be honest, it'd be way too easy if they, kept to their standard, and so this adds a bit of a challenge. I like a bit of a challenge when trying to find the adversary, Okay, what other fields might we be able to go see? So there's another field called user ID. This is like the system user that runs the scheduled task. So we can group back all those properties, get that nice clean list, and what we see returned is another instance where 47 of these tasks have nothing in the result. Microsoft's like, you just don't need to know those details, so we're just gonna hide them from you. Cool, thanks, appreciate it. Some administrator stuff, they've got a SID in there as a result. Just some really interesting, weird ways. There's no clear standard for how or why you should run scheduled tasks a certain way. So Microsoft, being the massive organization that they are, doesn't follow any good standard, which is nice and helpful. Now, similar to the user ID field, there's an author field. Author field is who created the scheduled task. So if we return back all of those details, what we'll see here is most of these created by Microsoft Corporation, no huge surprise there. And then we've got 48 results of, blank, probably Microsoft, just the, secret ninja Microsoft. What I especially love here is now we have Microsoft without corporation. So Microsoft Corporation, blank, Microsoft without the corporation on the end. And then up here at the top, there's a real fun one of Microsoft Corporation with a dot at the end. Just to be a little bit different, because why not? And this is part of the process, like trying to find those things, and it's really difficult sometimes, especially when Microsoft seems to be the biggest adversary in this space. One does stand out as a bit anomalous here is that user 01/administrator. So that's host name of the machine and local administrator account. When creating scheduled tasks, it's not necessarily a normal thing for the local administrator to create scheduled tasks within an environment. And so if we wanted to dig into that a little bit, we could filter on that scheduled task with the administrator as the author. And we return back this task. Task name as Intel sitting in the root task path folder. Again, that's that higher level metadata stuff. I want to know what is being executed, so I'll return the execution details. And inside that path, we can see that it is executing this explorer.exe. Except explorer.exe is running out of the administrator app data local temp directory, not where explorer.exe should exist. Cool? Okay, so this is the malicious task, and we could go a little bit further into doing file analysis on that executable, but we found it. Now, I showed you lots of different ways that it's kind of easy to hide amongst the normal legitimate tasks that exist, but this is pulled from an actual example of a larger named threat group that created a scheduled task for persistence exactly like this. Okay, so they often leave something to be desired in their own capabilities, despite being what we'd consider a higher level APT. So you can still find them, and you might be able to find things like this, but even more concerning is those other things that I kind of talked about. Okay. So naturally, my flow for this is, all right, I've done the command line analysis. I can scale that out, but probably not the best way to go filtering manually through all the scheduled tasks. So I would like to get that into a pretty visualization or dashboard so that I can start to find those anomalies a little bit easier. Thus begins my next miserable journey, is trying to get these scheduled tasks as they exist. Like I talked about before, they're in a directory. Each file is an individual XML file, and because I want them in Elasticsearch, because that's where my experience is, and I'm familiar with that tool, I need to get them into JSON format. So, cool. Sounds easy enough. I'll just get them from XML to JSON, ingest them in, and build some cool, pretty dashboards. Attempt number 1. No foreshadowing here. I'd love to say that I got this perfectly the first time, but didn't quite work out that way. So we start out step 1. I need to export the tasks. Like I did before, I'm going to go to PowerShell for this because I'm more familiar with this. I'm not an amazing developer by any stretch, but I can do a little bit of scripting. And so I wrote a quick little script with PowerShell. What this does is pulls back all our scheduled tasks, puts them in a single flat directory, and then gives them the XML extension. So nice and clean, cool. I've exported them from the box. I've put them in a folder of my choosing, and now they're named with .xml, so I can do something else with them. Step 2, I'm going to convert them now to JSON. Again, please don't judge my code too much. I've modified JSON a little bit with Python before, and so I went to Python for this, and I created this simple script. Effectively what it's doing is it's reading in all the XML files, and then it's converting your angle brackets to pretty squiggly braces, and trying to keep that structure within the fields so that it's now from XML to a JSON format, and nice and pretty squiggly brace, whatever format. Cool, so now I've got a massive amount of JSON files. Perfect. Step 3 is to import them into Elastic. Great. Not so much. So unfortunately, Elasticsearch actually requires them to be in ND JSON format, so new line delimited format. And it's a little bit picky about how it wants that ingested in. Okay, so attempt number 2. Well, actually, there's a tool called JQ. That's used command line to be able to view JSON files in a little bit of a prettier format so you can start to do a bit of analysis. You can also use JQ to convert from that basic JSON format to ND JSON format. Great. So that's a simple one-liner right there, nice and easy, and I'll import that into Elasticsearch. Great. Not quite. So it turns out these scheduled tasks are actually like multi-nested, complex files with fields, and they don't follow the same format from scheduled task to scheduled task. So Elasticsearch did not like how I tried to ingest those in. Okay, so attempt number 3. Back to Python. As I mentioned before, I'm an amazing Python developer, and so I just didn't include my code because it was so awesome and not because it was terrible. Either way, I wrote another script in Python. Effectively, what I was trying to do is flatten the structure of the JSON file, get rid of some of those nested fields, and make it easier or allow Elasticsearch to be happier as I tried to ingest this in. Now we import. Fail. Still too complex. I'm sure it had nothing to do with my amazing Python developing skills, and more to do with just Elasticsearch is making me super angry at this point. But either way, we're now on to attempt 4. Okay, so I was avoiding this from the get-go. I know the correct way to do this. The correct way to ingest a new file format into Elasticsearch or some other thing is to use a proper schema and a proper ingestion process. So that would mean, for Elastic, creating a logstash pipeline, which is more work than I wanted to do, which is why I was avoiding it. Logstash has an XML parser. Great. Okay, 30 minutes later, the task scheduler schema has 658 lines in it. And yeah, that's my life for the next month or more. So I gave up. Okay, so that is legitimately the correct way to do it. And I would love to stand in front of all of you and say I promise that I will get back to that pet project and finish it. I'm not going to make any promises, because creating a logstash pipeline from scratch is miserable and I need help. So if any of you know one that exists, and I tried really, 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 really hard to find one and couldn't, please let me know. Otherwise, maybe I'll do it at some point. So attempt number 5, I know another way I can actually get data in is, well, Elasticsearch will take CSV files. Well, okay, so at this point, I gave up on my developing skills and just pulled some random application off the internet, so I'm probably owned by Russia or China, who knows. But there's lots of tools that do the same thing. So I effectively just converted all of my JSON files over to CSV format. It super simplified all of the files, so now we're in comma delimited. Each field name is now just a directory path to the field name itself, and I've got a bunch of CSV files. And import was successful. Yay, I finally made it there. If you're familiar with Elasticsearch, the way that you ingest CSV files into Elasticsearch is manually dragging and dropping and ingesting those files one by one. So almost 150 files later, yes, they were ingested into Elasticsearch. No, that is not the way I'd recommend doing that for an enterprise. However, I wanted to create dashboards, and I ingested the files and created dashboards. So that's where we're at. For this, I didn't record the demo, so I'm sure it's going to fail. This is part of a Docker container that I'm making open source to everyone, so if you want to be able to sift through this data, if you want the dashboards and visualizations to yourself, part of this was an exercise in learning the schema format so I could better inform the logstash pipeline and figure out the important fields that I want to be able to create those visualizations for. So if I go over to dashboards, I created 5. Just kind of categorizing the data in different ways. So this is, I'll try to make this a little bit bigger. This is the overview dashboard. I like to start with just a, hey, high level, how many scheduled tasks do we have? Is there any big metadata pieces? There's a version for scheduled task. By the way, try Googling like scheduled task version and good luck. There's like a bajillion different things. And then down at the end of each one of these dashboards, I have a saved search. So if you want to dig into each one of these scheduled tasks to learn each one of the fields, gain more details, so on and so forth, you get that. So I'll kind of walk through these quickly. I think I'm doing decent on time. Just to show you some of the other fields and information that you'll see to give an idea about how we might find some more anomalies or might find some more different ways to find these malicious scheduled tasks. So this is within actions, right? So the actions or the execution details for each scheduled task. We see here, this is like the command field. If I go back out real short, each one of these has a count on it. So you get a nice clean data table list of, hey, how many times each one of these fields was seen or these results was seen. You can then filter on that and get the full details. Allows for full text search, so if we want to search for things like PowerShell or other phrases, you can do so. This makes it a much more sustainable way to do threat hunting. Of course, if you can get the data into Elasticsearch to begin with, but we'll bypass that for just a second. What's also interesting here is there's a field for working directory. So 2 of the scheduled tasks have this working directory, effectively a different location than where the scheduled task may or may not be created. Interesting implications there. And then a few of the tasks have data for COM handler class ID and COM handler data. Again, I'm kind of just walking through these as additional ideas that you might want to use or things you might want to go look for. So those are our action fields. If I go back, I've got principals, I've got a dashboard for principals. This is effectively that like ownership information of the scheduled task, things like group ID, the principal ID that the scheduled task is running under. Even though Microsoft hides a lot of the information in those hidden tasks, you can actually dig into the details. That digging in requires more of like going and finding the registry key entries that are being modified and then trying to Google what that registry key does to try and figure out like what Microsoft is actually accomplishing. So there is a process to learning what each one of those things are doing, but within some of these fields, there's things that aren't hidden. So you can gain a little bit more insight into what each one of the scheduled tasks is attempting to accomplish. Principal ID, there's run level, there's also login type. So based on the scheduled task, you can specify the kind of login type that it will then execute under. Interesting thought process there. Registration info follows that similar thing. So we've got that author-based information. URI is the file path to where those scheduled tasks exist. I get lots of errors about shard failures because it doesn't like the data format of any of these scheduled tasks as I've ingested them. Again, CSV is not the correct way to do this, but I have a dashboard. What you'll also notice up here at the top is a timeline view. Okay, so each one of these scheduled tasks also has a time associated with when it was created. The one that's way here at the end, 2022-07-26, that's when I created the malicious scheduled task. That is another great way to go look for new scheduled tasks that may or may not be malicious. What's worth noting about this data point entry is if I go back to the beginning, there's a task that sits there at 2005. This machine was not created in 2005. That is when the scheduled task was created by Microsoft, okay? 2 points to that. One, now you know that there's like older tasks that say they have older dates to them. 2, thanks. That means that you can modify that date to be whatever you want. So while this may be a useful point to say, hey, this is a newly created scheduled task, that's not necessarily an accurate field. Got some source description. There's the security descriptors if you really want to dig through those. That's a whole talk in and of itself. And some description-based information. Last dashboard I want to show you is the settings. So there's some really interesting fields inside settings. These are additional things that you can enable or disable based on how you want to run it. By default here, we have this cool field called hidden. There's 37 hidden tasks by default. That's separate from like hiding the information inside of it. That's taking the scheduled task and making it invisible inside Task Scheduler. Cool, thank you, Microsoft. That makes it even more helpful that you've added in those extra fields for an adversary to be able to hide with, right? 51 disabled tasks. Again, this is a brand new build of Windows and it ships with disabled tasks. Either based on your configuration or your build in the environment, they still exist. Those are legitimate things that if you're using something like Microsoft as a defense tool, it's going to ignore any Microsoft things. So if an adversary is able to modify any of those existing ones to do other stuff and you're not detecting on that, yet another way that an adversary can establish a more hidden or robust persistence. There's a lot of other settings set. These are all true, false type fields. Sometimes they say it's false or nothing. Sometimes they say it's true or nothing. And then sometimes the fields are true or false. You know, just because we don't like standards. Idle settings, do we want this to start or stop on idle? Do we want this to only run if the network is available? Interesting. Do we want to only let it run when it's idle or when it's going on batteries, or there is a unified scheduling engine piece and there's a whole nother train of thought with that? Either way, lots of data, lots of information here. I could probably talk about so much more than this, but I wanted to get this out because I can't find anybody else who's doing the same kind of research, who's saying, okay, what scheduled tasks already exist inside of an environment, and how do I find the malicious ones that are already there? Lots of things for detection, and please try and do detection, especially because you should be concerned about this persistence mechanism, but we probably need to get better at trying to find those malicious scheduled tasks that may or may not already exist within the environment. Okay, with that takes me to the end. I did want to leave a little bit of time for Q&A. My socials are there at the top, and then there at the bottom is the GitHub link that has all of the resources, some instruction, the Docker containers, script files, so on and so forth. I didn't include my super awesome Python script because, you know, I was too proud. But everything else is there. So thank you all once again. Any questions? Yeah. I'm working on it. So the question was, did you try and replicate how Microsoft is able to hide those scheduled tasks? And it is more complicated than I thought it was going to be. That was the question I hoped I didn't get. But natural progression, right? I think it's possible. Follow me on social media, and I'm sure I'll come up with additional things. I'm going to continue this research for sure, because I find it incredibly intriguing. So yeah, that's what I'm working on now, but I haven't successfully been able to do it in a way that an adversary would do it, right? That's realistic.
There's a sort of username for GitHub?
Sorry?
Your username for GitHub?
Oh, there is kind of a story. By the way, I'm known by like a bunch of different, oh, I'm sorry. Is there a story to my username on GitHub? My username is Oofles. I've also been known by VVCat and a couple other things, but Oofles was a made up word for when you can't remember somebody's name. And I'm really bad about remembering people's name, and so that like worked as a handle for a really long time. So not super interesting story, but yeah, kind of one. Yeah?
As a quickie way thing, is it possible to just search the dates of all scheduled tasks?
Absolutely, but like
inside, you know, I'm going to tell my semi-intelligent cousin, go do this.
So the question was, is there a way to search the date of the scheduled task for anomalies, right? There is. So just like how we pulled it with PowerShell, you can pull that date field that I showed in the dashboard visualization thing. What I did know is it is very easy to change the date when it's created. You can specify any one of those metadata fields, and if you don't specify it, it will create the date that you created it. Otherwise, you can just say, hey, yeah, this was created in 2012, around the same time that Microsoft created some other scheduled tasks. So yes and no. The adversary that I emulated was Fin7, and they're known to be semi-decent, yet that's exactly how they created their persistence. So your mileage may vary on that.
Sure.
Yeah.
I was just going to ask, have you found any persistent schedule tests that actually will give you privilege escalation as well? Because I know like Windows XP, back when like before SP2, all like scheduled tasks that you could create were always ran as admin. Or actually system.
Yeah, great question. Question was, have I found any scheduled tasks that are able to establish privilege escalation within the scheduled task? I haven't. I found scheduled tasks that if an adversary has already compromised that level of integrity, then they can run it within that integrity user. Though you've you've got my brain thinking about, like, can a user specify the user ID, which is the privilege level that it would run under. I'd imagine Microsoft would probably prevent that. I know in XP they did a really, really bad job at preventing those kinds of jumps, but I need to try it out. Yeah, I've not found any in the like wild though, if you will.
Did you explore using WinLogB and Sysmon module for WinLogB to get this data in?
Yes, question was, did I explore using WinLogB or any of the like beats functionality to ingest the data in? Yes, absolutely. The problem is they are structured in a way to format event data logs. Scheduled tasks as they exist aren't in a log format. They're in a scheduled task format, which is separate. And so if we were enabling those like event 4702 or whatever they are for new scheduled tasks as they're created, WinLogB will absolutely ingest the data in. But any existing scheduled tasks, because they exist in that really weird XML format, WinLogB won't read the data and pull it into Elasticsearch.
Sysmon reads the data.
Sysmon will read the data, yes.
That's what I'm saying.
Oh.
So the Sysmon module for WinLogB would pull all that in.
Yes, if you had enabled sysmon data and you have the data as the scheduled tasks are created, then absolutely you can view it inside of Elasticsearch.
So Sysmon as part of your initial system build would get all this stuff set for you.
Sysmon as part of your initial build, would it get all the data for you? Sysmon doesn't actually return all the information that exists inside the scheduled task as metadata fields. I've got 1 minute left. But it will give you most of the important information on initial build. And if you're starting with a clean build, then yes, you'll get all that data. I think I saw back corner first.
Yeah, I was curious, have you seen or heard of any threat actors or even red teamers modifying the existing legitimate Microsoft scheduled tasks for their own persistence? Is that something that's common, rare, hard, easy, novel?
So the question was, have I seen any threat actors modifying the existing Microsoft scheduled tasks to establish persistence? I will say that it is not difficult to modify existing scheduled tasks to do what you want them to do. I'll leave it at that. My time is up. Please, please, all the questions, come find me. Absolutely willing to talk more about this. Thank you all once again so much for coming to this talk. Hope you enjoyed it.